Welcome everybody to our next AiM Sports Learn Fast webinar. This is the 83rd webinar we've done since we started last March, and we're going to continue on for a while. Those of you that are signed up and watching these live, I am going to extend the schedule. You'll get that email here probably in the next week or two. We've got about 5 or 6 more that are scheduled now, so you'll get that coming up soon. We're going to go ahead and extend it for a while longer, so keep that in mind. This one here we're going to talk about is practical CANbus basics in the AiM Sports universe. We've chatted a little bit about CAN and some of the technical details, and we will again because it's just such a technology that is coming at us, fairly quickly, and it's getting easier to understand. Our software is getting better around it, so we're going to continue to chat about it. But today we're going to take a little bit of a different approach to it and talk about connecting CAN devices to your AiM dash loggers and basically just get into not 100%. We'll talk a little bit about what is CAN and how does it kind of work, but it's more, well, I've got this device, I've got this RaceVoice, or I've got this, this other CAN device. We've talked a lot about tire pressure monitoring. Okay, I've got this. How do we make this thing work, right? And how do we connect the two in a fairly basic way and just solve my problem, make it work, and move on? So we're going to talk about that quite a bit. So let's go ahead and get started, and let's go to got a couple of co-hosts today. I'll introduce one at a time, have them talk a little bit about what we're doing, and then we'll jump into this. Our first one is Jeff Wasilko. Jeff has been active, very active in our webinars as a viewer. He's a friend of mine that we've chatted for years. I've known Jeff, so he's going to come in here and he's going to give us be a co-host for the first time and talk about this CAN basics. Thank you, Jeff, for doing what you're doing here today. I know it takes a little, a little bit of extra work, put it all together. We do appreciate that. So tell us a little bit more about yourself, and then we'll introduce our second co-host.
Sounds good. Yeah, it's been fun working on this with you. I've been doing DE and racing since 2004, and started with a race pack data system in 2006, and very quickly switched over to AiM. But data has been the one consistent thing that's allowed me to sort of get faster and stay faster. And I've been just a huge fan of the products that AiM has, and I've really benefited from the ability to analyze my data, and I've also been a real advocate trying to get other people to look at their data too. So we started a coaching program with the Time Trial Club that I'm active in, and we're just trying to get people to do more than just look at it as a lap timer, but actually get your laptop out, figure out how what questions to ask and how to get faster.
And Jeff is one of those guys that I don't laugh at, of course, but I feel kinship here because when I first met Jeff, he had I think he had one Miata and a little bit of he was just kind of getting into it, and after a while he had 2 Miatas and he's got a hauler and he's working on stuff and he's got data everywhere. He just very much right in the same path that I followed, right? You get into these things and and it sucks you in, and so much fun. So
my wife, who's with me in the picture there, had a Miata for a while, and she glommed onto the data really quickly too. She's very visual and analytical, and she was able to look at the graphs and consistently get quicker too. So that was fun.
And quick as well.
Yes,
so, and the only bad report I can have is I went and attended one event at New Hampshire that one of the COM sports car clubs events one time, and so I was there and I was having a good time and chatting with all the different users, and she spun her car and backed it into the wall. It was so the only one I was at, she actually dented her car, so that was not good. I blamed it on me. So.
I didn't know.
Yeah, exactly. And our other co-host is a many-time webinar co-host, Robbie. Robbie is going to join us today with a little bit of AiM wisdom on CAN stuff. He's kind of our CAN wizard, and so we're happy to have Robbie here with us as well. Robbie, you got a couple things you'd like to add before we get started?
I'm just happy to do another topic on something that I really enjoy. And I think we spent a good amount of time just talking about the evolution of CAN and how easy it is to get into and to make hardware systems communicate together, and what we've done as a company to make it even easier. And that's what we're going to try to get out to you guys today.
Perfect. Thank you, Robbie. We're going to have a poll here today to start off with. Give Robbie and Jeff just a little bit of an idea of your background with CAN. So I'm gonna start a poll, and let's see. Let's make sure it's working. There it is. And we're calling it. What is your experience with CAN? Go ahead and answer that. It's a one answer only. So I think once you lock in, you can change it a little bit until you submit it. But pick one of those and give us an idea of what your experience is. We're gonna let that poll go for about a minute, and I'm gonna go ahead and jump ahead one screen and just kind of get up to the beginning and Jeff, while there are finishing that, let's go through this screen and talk a little bit about what we're going to talk about today.
Yeah, sounds good. And let me give you, I can give a little background of sort of why this sort of came together. I started on the slippery slope of throwing lots of CANbus devices in my car back in 2019 when Trailbreak and Matt Romanowski came out with the really inexpensive TPMS. And while I was working on that, Steve Spano, who's an SRF racer from upstate New York, came out with this device called the RaceVoice, which lets you do sort of audio coaching in the car. And one of the things that it does that I think is most amazing is it can tell you min corner speed and exit speeds in corners, which is something that the AiM system can't do. There's other data systems that can, but it's always something I wanted. I felt, especially in a Miata, min corner speeds are key. And so I went from having one device to two devices, and the RaceVoice had never been supported on a device with other devices on it. And so I sort of stepped down this path of working with them to try to figure out how do you get the right speed, termination, troubleshooting. And because I was the first person with two devices together, I actually had some problems. And so I had to learn about CANbus basics. And so I thought this would be a really good topic to talk about, because I think we're starting to see all of these sort of aftermarket, low cost, even in some cases, sort of enthusiast driven products like the RaceVoice or the TireX from Autosport Labs, or the microPDM from Matt Truden, who's an Spec E46 racer. We've got all these folks who are like car geeks, but they're also geeks in other forms, and they're coming out with these really cool products. And so the ability to integrate them into a car, with a fair amount of simplicity is a big game changer. So back to the basics here. CAN stands for Controller Area Network. And the idea is you can have multiple devices on one bus or one set of wires, and the devices can communicate with each other, right? It isn't like you wire from point A to point B, but all the devices can share information because they see the same data. And so today we're going to talk about using the AiM dashboard, and in my case I have an MXP, as the hub that lets you link all these different CANbus networks together, and more than just link them together, but actually make it useful. So should we take a quick look at the survey results?
Let's do it. I'm going to end the polling. It looks like almost everybody voted. I think there was a 9 or 10 of you that didn't vote that are here. So I appreciate everybody doing that. Let's end that polling and let me share the results. Bring that up for everybody to see. There you go. The poll for the YouTube viewers, they don't get a chance to see the panel. So the question again was, what's your experience with CAN? And the number one response was none, but I'm interested in the topic. So there's a lot of people here that are, at 38%. There's a lot of folks here that are really interested in learning a little bit more about it. They're kind of the same level of answer as the second one. I can spell it. So we have to add that 25% into the 38 of people that are feeling out this topic and try to get an understanding. The next highest was 12%, down in one of the lower ones. I have 2 or more CANbus devices on my AiM Sports expansion. So using that private AiM CAN network, I think is what that's probably external. And then I've connected my ECU to my AiM Sports via. So there's a lot of folks here that are, and then of course the last one, I am. There's 7% that I am a CAN lord. Hexadecimal and binary are my servants. So we've got a few people that are pretty darn good at this. So very, very cool. Again, a wide variety of users that we're looking at. So we'll stop sharing those results now, and let's bring that up over here, and go to the one last thing I would like to make sure those of you that are here live that we are going to take questions and answers as we go. From the question and answer box. So while we're chatting in the chat box, make sure you open up your question and answer box and type in some questions over there that we'll feed in when appropriate. I do see Andy's question there. That is actually part of a topic we're going to chat about during the webinar. So leave that one there, and we will cover that one. Okay.
It sounds like we've got a good audience, that folks that are interested but haven't really dove in, and that's our goal with this. Is we're just going to keep it fairly light, just sort of enough information to be able to take a couple devices, plug them together, and kind of make it work.
Perfect.
And if we could, before we switch the slide, the image that you made, Jeff, is fantastic. I don't know if we show this again in the other
we do,
slides.
Later, bigger.
But this is the goal, right? We have an MXP acting as a pass-through device for all of these different electronics. So you want a tire pressure system, you want a microPDM, you want a Rio, a SmartyCam. All of these things have to communicate. And the goal today is to demystify how all of this is done.
And the other piece of that is some of these are AiM devices, some of these are external. Robbie said that, but it makes it even more powerful to me as an end user, and to all of our users here. So let's jump up to the next slide here, and Jeff, you want to start chatting about this a little bit? Talk about why did we use it? We kind of touched on it a little bit, but why CANbus?
Yeah, so I mean, if we think about why CANbus, and maybe think back to what AiM did, particularly from the change from the old optical beacon to GPS, right? That was sort of like the start of having things on CANbus. AiM made their CANbus, the private CANbus, really easy, right? It's just plug and play. The connectors are already done. You can add devices pretty much to your heart's content, and it just works, right? I think that's one of the things about CAN is at most levels, it will just work for you, even if you're doing it yourself with other people's devices. And so if you think about all the things that you can buy from AiM, the dash is the GPS, the SmartyCam, shift light module, channel expansion, memory module, the Rio, the new switch module that just came out, like all this stuff, you just plug it in and it works. And as I talked about a little bit earlier, right, we're seeing all of these other network systems come into play as well. We've got the tire pressure monitoring systems that are super inexpensive. Tire temperature systems are still a little pricey, but I think in a couple of years that's going to be sort of something that's kind of a no-brainer from a cost perspective too. Pretty much every ECU these days is CANbus connected. Like the days of serial link is pretty much dead, thank God. And then there's a huge variety of aftermarket power distribution modules, and then AiM has entered that market as well with a PDM and a dash together, which is really an amazing product, and the expansion modules that are coming as well. And then other things, right? We've got the things like RaceVoice, where you can have thing whispering in your ear what your corner speed was, or telemetry, like what's your pulse rate, what's your temperature of you, or when we do endurance racing, we have a system called the it's the Podium Connect, that from Autosport Labs, that takes the data from the AiM bus and transmits it over cellular data back to the pits. So again, that's all CANbus. And then we've got sensors, that are coming out as CAN first as well, and keypads. And the real advantage of CANbus is it's just 2 wires, right? You can run a 2-wire twisted pair network through your car and connect sensors to it, different places in the car, connect devices to it in different parts of the car. And the CANbus itself is it's robust and reliable. And part of the reason for that is the fact that it's 2 wires. And we'll talk a bit about this later, but the way CANbus works is through a technology called differential signaling. And so the uses one low voltage wire and one high voltage wire, with the idea that interference is picked up on both wires equally and sort of cancels itself out. And so it's in a noisy electrical environment like a race car, it's very robust. And sort of a funny story there, I was rewiring the car that I bought and discovered that the previous owner wired the CANbus link from the ECU to the dash with like 16 gauge copper speaker wire, not twisted like something you just plug your speakers in. And it worked for years, right? And it's just like we can get wound up in the crazy technical bits of CAN, but in the end it will just work, right? Like you have to work pretty hard for it to not work. So don't sweat the details. You can dive in and it'll probably work for you. Any thoughts on that, Robbie? Or?
Yeah, I mean there's a very detailed industry standard that we always strive to meet, but I have had so many applications where you walk into something, someone else's wiring, and you look at it and you're just like, all of this is working. And I mean, it's just wires everywhere, bound up, looped around, right next to
Yeah,
the
exactly.
stator, right next to the coil, and everything's still communicating. It is a very robust system. So if we could just hammer that point home, is that we don't need to really focus on the minute details of 3 twists per inch and no longer than
Exactly.
15 meters. Yes, it's great when we can implement those types of tactics, but it's not always required. And I have lots of applications where it's just 2 wires running straight back to where the device is.
Exactly.
Your professional harnesses you make look so cool when they're all twisted up, Robbie, and
Thank you.
Cameron both, right? So yeah, I like the look of it. Perfect.
Cool.
Let's jump to the. Oops, I jumped to. Maybe you covered some of this, I think, a little bit already in your talk, Jeff. But we'll pause there and let you chat about that slide a little.
So the other big advantage of CANbus, right, is it's sharing, right? It isn't just point to point, but it's a network that allows one device to see what another device may be sending or interact with another device. And give us some examples of that, right? We can take the tire pressure monitoring system, tire pressure data, and send it to the SmartyCam to be rendered onto your video. And so in the example in the video here, you can see I've got the 4 tire pressures showing up on my SmartyCam video, which is really handy to be able to see live. You can have other bits of integration, like the RaceVoice could hear from the AiM dash that your ECU oil pressure is low, and actually give you a warning that your voltage is low. Another example we're going to walk through is the PDM can turn on a brake light based on the brake pressure sensor. So again, the analog sensor connected to the dash can tell a PDM to go do something. And then you can do other bits of integration with analog switches. So you can have switches that then get translated into a CAN action. So you could have a physical button on your dashboard that would change a page on the AiM dash, for example. So it's not only robust and reliable and easy to use, but it lets you start to think about other bits of integration as well.
The more you know, the more you want to know, right? Because it's just there's a lot of, it can do so many cool things once you kind of open up your mind.
Yeah.
Perfect. We do have a lot of questions in the question and answer. Please continue to put those there. Robbie, you're probably scanning those as you and Jeff as we're going. Fit those in as you see fit, if you would like. Okay, Jeff, let's talk a little bit about AiM Sports and CANbus and what we have multiple networks, and let's talk a little bit about how that works and to the end user.
Exactly. So this sort of sets the basis for what we're going to talk about a bit later. So all of the modern CAN dashes, which is the MXL2 and newer, have 3 CAN buses built into them. There's the private CAN bus, or the AiM Sports CAN, or sometimes referred to as CAN 0. And that's used for all of the AiM devices, things like the GPS, the SmartyCam, shift light module, basically anything that you buy from AiM gets all plugged into that device. There's also some other interesting devices that are worth mentioning that sort of take a little bit of a unusual approach, like the Podium Connect or the RaceVoice. They can actually plug into the AiM private bus and just listen, and they sort of snoop like they're a SmartyCam. So they get the same channels that your SmartyCam gets, and then they can do things too. So like the RaceVoice can tell you, hey, your oil pressure is low, or this was your lap time. And the Podium Connect can send all of those channels back to the pits if you're in an endurance race, and you can keep an eye on your speed and GPS location and all of those things. And so that's interesting. And like it sort of historically, that was the only way to expand. Like if you had something like a Solo 2DL that only had one bus. But that was not great, because we were trying to sort of shoehorn ourselves into somebody's private party. The second CAN bus that's on the modern dashes is CAN 1. It's typically used for ECU. And it's worth noting that if you use an AiM Sports provided config, that's the only thing you can put on there, right? The config is basically locked, and you can't add other devices to it. You can certainly go your own way and build a custom config and add a device, add multiple devices on that CAN bus. I think from a functionality perspective, it's the same as CAN 2. And then CAN 2 is supposed to be the device that's sort of the expansion. It's the open one, right? Not used for the car's ECU, but used for everything else. And as I said, you can use multiple devices. Right now, you can load a single config, and if you want to add a second device, it's a bit of a manual process because you need to do that by hand. There's not currently the functionality to load multiple configs together and merge them. I don't know if Robbie, if you had something to add on there.
Yeah, actually, it's for Andy Whittle's question, is it possible to add new channels to existing sets? No, but it will be. We are actively working on a few things for our ECU driver builder to make things easier. And that one of them is to amend the ECU driver, so you can take a proprietary data set, something that we don't give access to, and add channels to it.
That's cool.
And it makes it a lot easier for someone who doesn't have the time to go through and get the CAN information all organized and build an XE1 template with their additions. They can simply take something that's already working and add to it. So hopefully ECU or CAN1 will be a little bit more robust for our end users.
I think that just goes to show again that how much the CAN stuff is maturing in the environment, and it's gone from, hey, you can only have one device on this, to being, hey, you can have lots of devices on multiple buses. So yeah, good news. And then so as we're going to talk about in this webinar, the dash becomes the hub or router that links all of these three networks together, enables data sharing, and enables you to take actions, right, and do this integration between all of the devices.
And Todd asked a question there that I think fits onto this page. So we'll knock this one out pretty quickly. Isn't the SmartyCam restricted in what data is on
That's
the stream?
correct, and it's one of the limits. Like if you were going to implement something like the Podium Connect on the private bus, you can only use the 16 channels that are available to the SmartyCam. So that would be a good incentive these days when you have an extra CAN bus to throw the Podium Connect on the CAN2 and go that route.
And our ability to add to existing ECU protocols that hopefully we'll have at some point in the near future, that will help that as well, right? So they can get the channels they want.
I don't remember exactly, but I think the Podium Connect was around before there were the modern dashes with 3 CAN buses.
Yes.
So I think that's kind of what their design perspective came from. So yeah, I mean, how far we've come in 3 or 4 years.
Very little time, right?
Yeah,
right.
yeah.
Perfect. Okay, let's go to the next slide. Oops. There we go. I think that was the next one. Let me double check that.
Yep, I think we're.
Let me do that. Okay. Yep, there you go.
Yep, we're good. So I just wanted to take a quick walkthrough. So I have a very small car up in Miata. I think I'm running a little race here with Matt to see how many devices I can throw in the smallest car. But I wanted to sort of show a graphical illustration of the sort of devices in the car, but also how they're linked and how they link back to the MXP. So if we walk through the private bus, the AiM CANbus, I've got the MXP as the core, shift light module, a remote button interface so that I can control the dash from my steering wheel. And then if you look sort of at the top right there, I've got a memory module so that I can just pull a flash card out to download data. I just added a Rio 02, which is a new switch module that I'm excited about because it'll let me add a few more buttons to my steering wheel because I don't have enough buttons. I've got the SmartyCam, which is kind of key for stuff these days, and then the GPS, and that stuff all sits on the private AiM bus. And then sort of off on the corner there, I've got the
color-coded red here in your graph, right?
Yep, and that's all the stuff that's on CAN 0 or the private CAN bus. And then if we jump up to CAN1, that's typically where the ECU lives, and in my case, that's all that's there. I've got a Haltech ECU linked directly to the MXP, and I think hearing that there may be some options to add more devices to that later will be that's good news to be able to know that I've got another bus to expand into if I need it. And then the CAN2, which is the fun bus, I've got as I said earlier on, I started out with a tire pressure monitoring system and the RaceVoice. And over the winter was starting to do some rewiring in the car. I didn't like some of my accessory wiring, wanted to do a little bit of cleanup. And as I mentioned, Matt Pruden, who's a Spec E46 racer, came out with this really cool accessory PDM called the microPDM. And really cool form factor, low cost, uses a standard Blink Marine keypads, which everybody's used to seeing in sort of race car CAN installations. And so added that over the winter and started to play around with some of the integrations there. And that's kind of what spurred this, the idea to do this conversation.
Perfect. Let's go to.
And then if we jump ahead, just a quick photo tour. So top photo, I've got the microPDM. It's in a, what do they call it? It's a weather packed Micro 280 enclosure. And then the RaceVoice, which is the audio coaching on the right side. And then on the bottom right photo, again, the microPDM, the Haltech ECU, the tire pressure monitoring system from Trailbrake, And then on the left side, the MXP with a couple of old school dashes or gauges. And then in the bottom right, the Blink Marine CANbus keypad. And that's the cool thing about CAN again, right? Like everybody uses that keypad because it speaks CAN, right? It's just a off-the-shelf standards-based product. What a wonderful world we live in.
Perfect. Perfect. Status variables. Now we're getting, we've talked about what makes this, what's kind of the cool part and how to lay it all out and how we can add things back and forth. And now we're going to dive in a little bit into the meat and potatoes of this, right? So let's chat a little bit about this, Jeff, and explain what you're talking about when you talk about status variables.
Great. So status variables were a fairly new feature in on the newer dashes and in Race Studio to allow you to basically look at a number of other conditions and evaluate those to either something that's either true or false, which then becomes useful elsewhere in the configuration. So in this particular example, I have a status variable here called SV brakes, and it's just set to say it's true when all of the following conditions are true, right? And then there's only one condition at this point, but if brake pressure is greater than 35 psi, that status variable becomes true or 1, else it's false or 0. And with this, I can then I'll use this later in our practical example, where I'm actually going to send the content of that status variable out over the CAN bus directly without doing anything else. And that becomes the key to control devices on the CAN bus by just changing what a status variable is. So any thoughts there, Robbie? Or?
I became addicted to status variables. And we talked about this. It's the beauty of a status variable is that you can call to it from other tabs. So we create these status variables. They can be logged. We can see the events in our data, and I can output them on the CAN bus. I can also set my alarms by them. So I can build all of my status variables, whether I use them or not, and then use them throughout the configuration. So it's a really powerful tool. I think it gets a little bit of underuse because you can build all your alarms. You can send just the CAN data out, but if you take the time to build the status variable side, you can just say, if this status variable is true, turn on my alarm, broadcast on my CAN output, and everything comes from the status variables.
Yeah, it's very cool.
And status variables are,
which is really handy too.
The logging part is important. We have touched upon status variables in some previous webinars, but we are planning probably in about 2 weeks to have a webinar that talks deeper about status variables and how you would use them in the bigger picture. So that's some of the cool things they can do that are beyond even the alarms and some of the other things. So that's coming as well. Great. Perfect. And the demo 1. And here's where we're going to actually go in and show a little bit about how Jeff put together a process. Here is his problem. Here's the discussion that he wants to chat about, and then we're going to walk through and show you how to do this, right, Jeff?
Exactly. And my goal here is so I sort of had a problem. I was adding a rain light over the winter to be compliant with one of the race series I'm in. My car was a little hack wired, and I didn't have a positive triggered brake light switch, which the rain light needed. And it occurred to me, I just put a PDM in, I can do this over CAN bus. So like, why not take it to the overkill and do it in the coolest way possible? So my goal with this demo is I'm going to show the documentation for the microPDM and basically just show, without having to dive into the complexities of like what all this stuff means in CAN, but just to be able to look at a vendor's documentation, look at what is in Race Studio, and sort of just copy and paste to actually create a CAN action without having to really dive into the complexities. So yeah, if we want to switch to Race Studio Live, we can.
Perfect. And while I'm doing that, I just want everybody to know that those of you watching live, we've probably already linked this presentation. There's lots of great information in there for you to download and read as we're doing this. But all of the links, anything we mention, if you're watching this on YouTube later, that will be down in the description box. So anything we talk about, go down to the description box. You'll have all the links there as well. So
while you guys are getting that going, I'd like to take a minute to address Bruce's question.
Okay, do you need the presentation, or can you just talk your way through?
As someone is starting out, what would be the foundation and what recommendations would evolve the system? As someone starting out in CAN, the best the best teacher is experience. You need to get a CAN sniffing device, and you need to start playing around. Don't be afraid to make mistakes or to not understand it. The more you immerse yourself in it, the more things start to make sense. It really isn't as difficult as you think. There's just a lot of small steps, and if you miss those steps, you can get lost. But you're not going to do much harm without transmitting. So
and I think more than having, like, you don't necessarily, to just start out, you don't need to go get a CAN sniffing device. You may just be able to follow the vendor's documentation, put some stuff into a config and try it out. And we're going to talk about some troubleshooting and debugging steps at the end of this. But I went through some fairly complex troubleshooting when I was integrating the TPMS and RaceVoice. And most of it was divide and conquer and sort of just basic engineering troubleshooting that you might use, and also talking to the folks that built the products. And it's one of the things we'll talk about too. There's a lot of folks out here who want to see you succeed, because this stuff's cool. So if you ask around, you can get lots of help from the community. So great. I'm going to grab control here. And
there you go.
So as I've talked about in the example, I started out with with tire pressure monitoring system on my car, and wanted to add RaceVoice to it. And I'm sorry, I'm talking about a bit of a long thing. I've got a configuration now with RaceVoice and tire pressure monitoring system, and I'm going to add the microPDM to the mix. And I'm going to use the microPDM to turn on my brake light when tire pressure or when brake pressure is over 35 psi. So let's see. We've talked a bit about the AiM software, right? We've got things we talked about here. We've got the ECU stream, which is the CAN 1, CAN 2. This demo, we're only going to need to use a feature that's all the way over here on the right, all by itself, called CAN output. Because actually, let me step back because I jumped ahead. I need to do the status variable first, which we talked about. I'll just give just a quick walkthrough here. So under the status variable tab, we've got the status variable brakes, which we talked about earlier. It's set to be true when brake pressure is over 35 psi, else it is false. And one of the things to know if you're not a hardcore computer person, right, in computer ease, 0 is false, 1 is true. And so if you know that, that comes in handy later when we actually go to say, hey, I want to turn a channel on when this is true. So does that sound good?
Okay.
So we're going to jump over here to the, bail out of this,
Cancel that one.
To CAN output. And the CAN output, again, has a suggestion, has the options for both CAN 1 and CAN 2. But in my case, I've got my microPDM on CAN 2. And so what we're looking at here on the right-hand side here is the vendor documentation from the microPDM. And then, so in my case, right, I want to turn on a button, which is the sort of the way that the microPDM thinks about things, right? Everything is button centric. I want to turn a button on when my brake pressure is over 30 psi, 35 psi, and I want to turn it off when it's under 35 psi. And remember, I mentioned earlier that 0 and 1 is what the status variable, resolves to. It's either off or on, false or true. And so if you look at this example here, which is going to just get all squirrely on me, it just happens to be, if we look at the documentation, right, for button action, it gives me an identifier, which we'll talk about in a minute. Direction, right, this is to the microPDM because I want to turn something on. And then it gives me basically a description of what I need to send it to turn a button on. And it walks me through these 3 bytes. But interestingly, the last byte, or byte 2, just says 00, is off, and 01 is on. So, pretty much easy, right? I've already got a way in AiM land to create a 0 or 1 depending on my brake pressure. I just need to send it out the network.
And we're talking about the microPDM right here, but what you've shared with me in the past is virtually every CAN, any hardware that's out there, it's expected to be used, gives a documentation just like this. So you'll have this information that you can help
like
build this.
Yeah, but I'm kind of a geek. I actually just pulled up the Tire X stuff, the new stuff that Autosport Labs is doing with tire temperature. Just was looking through their docs to see how they do things. Right? Every vendor is going to give you documentation like this. So, and it's always going to be about the same, right? Every vendor is going to speak about the same thing. So once you do one of these, the other ones become a lot easier.
Okay.
And so in this case, I can just sort of start to copy and paste information from the documentation, right? I want to copy the identifier. And in this case, you do need to know a little bit of something. You need to know whether it's a 29-bit or 11-bit or what is it, standard or extended. And there's actually a mention of this earlier in the documentation that says that this is, everything's extended. Also talks about the byte order, which we're not going to get really deep into, but depending on the kind of hardware that's running the CANbus device, the order of the bytes on the network will either be going in one direction or the other. And you just need to know that, right? You don't need to know why. You just need to know, okay, this device is a little Indian device, so I'm just going to pick that. And then the other decision you need to make when you're setting this up is, what frequency do I want to send this information from the AiM device to my CAN device? And so, you know, if I want to be able to have a very quick reaction to my brake pressure coming on, I might want to pick 50 Hertz. Earlier, I set up my status variable to also be 50 Hertz, so it's good to have those things match up. So once I've defined the identifier, now I need to define the message. And so now I'm just going to walk through here, right? So if we look at this, I've got byte 0 and byte 0, so it all lines up. It's really easy to, again, just sort of copy and paste this. I'm just going to copy the static value.
There are some software programs or documentation that don't consider byte 0, so it'll be 1 through 8. And at that point, you just shift, you offset by 1. So we go 0 to 7, some go 1 to 8, and you'll find small discrepancies like that. But I think just a dose of common sense, you still have 8, and you just move everything around.
Exactly, that's something that's in sort of in computerese, right? In computerese, the first thing is often 0, and you start counting at 0 just to be complicated.
Right. So when you're counting, it's 0 or
exactly,
0, 1, 2, 3.
Right, so we've got this, I've got byte 0, I'm saying it's only 1 byte long, and I'm gonna use the static value 0, 2. And in the documentation, right, this says that this byte, if I set in byte 0 as a value of 2, that's telling the microPDM, I want you to do a button action, right? And this helps differentiate it from other types of actions. And then, so now we'll go on to byte 1. And again, we wanna just send 1 byte. And the next byte we're sending is the button key number, and it says over here 0 index. So again, we're computer people, so we're being difficult. So if I wanted to send to button 5, right, that's actually 0 index, so that would be 4, right?
Mm-hmm.
So that's pretty easy. And now we get to the real magic, right? So I've already said, I'm going to send a button action message. I want you to do button 5, which is ID 4. And now I just need to say, what do I want you to do? I want you to turn the button on or turn the button off. And so I pick a channel that I defined earlier called the status variable, and I just pick status variable brakes. And I think this was one of the things that it took me a minute to get my head around, is that I don't have to write any logic that says when to turn the brake light on or when to turn the brake light off. The AiM is always going to be continually sending a message saying brake light off, brake light off, brake light off, brake light off. Oh, brake light on, brake light on, brake light on, brake light on, right? And then when you take your foot off the brake, brake light off, brake light off, brake light off. So there's no, particularly the way we're doing this, right? There's no state. It's just always sending what it wants it to be. And I think as I was trying to figure out how to do this in the AiM software, it took me a minute to sort of come to that realization. Then I realized, well, this is really easy.
Yeah, we're constantly sending the info. I think we're sending state 50 times a second. Is what we,
yep, exactly.
What we decided. So 50 times a second, you're getting an update on what your brake is doing.
Exactly. And so then the PDM will react to that and either turn the brake on or brake off. So it's that easy, right? All I did is I looked at the documentation, I copied the identifier, I copied the 3 bytes and pasted them into the AiM software. And then I'm going to save my my CANbus config, and then I would transmit this to my dash. And you know, the way I tested this was I got in the car, put my foot on the brake, and the brake light came on. It was like magic. So anything else we should talk about here, Robbie? I think that was the goal of this example.
I love it. The CAN IDs, it's an odd numbering choice that you use. I don't know why I thought of that, but 50 to 53 to 55 to 5A. But
oh, that's all stuff from the RaceVoice. So that's what was in here previously. So that's the RaceVoice getting the broadcast of all the things it needs, the throttle position and.
Right, and we did talk about the 11-bit and 29-bit, and you have two great examples here. You can see that the 11 bits are just a much smaller value. They're 11 bits of information. The 29-bit gives us a lot more identification for our CAN ID. We have a longer CAN ID. Yep.
And in this case, again, we didn't need to know necessarily the why, but I could have just copied this from the from the RaceVoice documentation. And actually, the guy who built the RaceVoice, Steve Spano, if you're starting out with some of this, he'll actually build a config for you. You tell him what you send him your AiM dash config, and he'll send you back a CAN config that does this, which is really nice. So that was my first thing, sort of entree into doing CAN output, and it was really nice that Steve helped out on that front. So cool. I think we can jump back to the PowerPoint deck.
Okay, let me jump over to there. Boom. Oops, I always grab the wrong one. And you want to go to demo 2?
Yeah, let's do that.
Oops. Quick
There we
mouse.
go.
Quick mouse. Okay, talk about what. So we just turned on a brake light. We could have done that some other ways, but it was a cool example of how this would work. Now we're going to talk about demo 2. What are we going to show how to build a CAN channel for this?
Yeah, I think actually, Todd, we had a question, or I just saw we had a question from Doug Carver about the,
Okay.
About things, but we can answer that real quick when we jump back into. We'll actually answer that when we jump back into the live software. Just
Okay.
give a quick introduction here. So we talked a bit about the sort of the output side of CAN, right? We talked about the CAN stream. The CAN output part of the Race Studio software. Now we're going to talk about receiving information at the AiM dash, or basically sending information from a CAN device to the AiM dash, which is what's called the CAN2 stream. That would be analogous to the CAN1 stream or the ECU stream as well. And as I mentioned earlier, right, when I first started out with things, often vendors can send you a predefined configuration. Like if you get the tire pressure monitoring system from Trailbreak, right, they'll send you a pre-built configuration file. And you can just load that in and you're pretty much ready to go. Just set up your channel names and you're done. And so we're going to talk about from this perspective, though. I already have the TPMS in here, and I need to add my microPDM to that mix, which means I can't do that automatically. I need to sort of do it by hand. And so we'll walk through adding a button status, which is interesting because it's just a bit field. And then we'll talk about adding a current sense channel, which is actually the PDM saying how many amps that circuit is using. So we'll walk through one each of those examples and then sort of show a built config. And just the picture below, that's what the microPDM looks like. It's really kind of cool because it's the form factor of a relay. So there's the microPDM and then an add-on, and then a couple of traditional relays and fuses all in a little fuse box. So really cool innovation from the grassroots.
Okay, you ready for the Race Studio software again?
There, that's good.
Okay, boom, and you can just click
Yeah,
once, and then you're off and running.
So, yeah, so the question that was asked from Todd was, can you elaborate on why I didn't copy YY? And so what the documentation says is it's the button key number 0 indexed. And so the thing to know about in this case, this is sort of keypad centric. So I have a 12 key keypad. If I wanted to turn on button 0, that would be, sorry, if I want to turn on button 1, that's actually 0, right? Because it's 0 indexed. If I want to turn on button 12, that would be 11, because again, counting up from 0, 11 is the 12th button there. And so I'm just basically saying turn on button 0, button 1, button 2, button 3, button 4, and so on. And so that's why I had to provide, in my case, I turned on button 5 ID 4, because that's where I happen to wire up the brake light. So it's basically where, the circuit that you want to turn on, or the button you want to turn on is what drives that. And then the documentation, oh, go ahead.
And in a lot of the documentation, you'll find like XX, YY, ZZ to let you know that it's a placeholder for a dynamic number.
Exactly.
So
perfect.
It's for you to input what you want to do with it, but it needs to be in this format.
Yep. Beautiful. So while we're talking about documentation, we'll jump down here a little bit if Paige wants to scroll for me. I'm going to walk through 2 examples, okay, because this is a PDM. I care about 2 things, like is the switch on or off, and how many amps is being used by that circuit. And so we'll do one each example of this if I can scroll this and get it all fiddly here.
Hard to do while you're over the
exactly. It's a little challenging. So for this case, we're going to leave the configurator and jump to the CAN config part, which is this CAN protocols button. And as I mentioned in our example that we're going to walk through here, I already have a tire pressure monitoring system in my. Oh, that's interesting.
Yeah, that shouldn't have done that.
Let's see.
I think we unlocked the top one.
Let's see. Yeah, that's the bad example, though. Let's see. Roger, you want to help me out here?
I certainly can, but I don't know what to type in there. So
let me try it here. Let's see.
I'm sure Matt's here.
Yeah. Let's see. There we go. Got it. Okay. So in my case, I have this configuration already running in my system. I need to add a device to it. I can't open up a config that I got from somebody else. I need to do this by hand. And so one of the things I want to do before I jump in here is I want to make a copy of this, right? Because I want to have a backup. I'm going to clone it. So we'll click on this and clone it. Click on this and clone it. Not going to cooperate, is it? Running without a net.
Out there.
It could just be that it's a manual collection. When you clone it, it doesn't go into the manual collection.
Oh, okay. Yeah, it's probably not in my manual collection. It probably cloned it.
Let's see. Come on. Not having a good day, are we? Worked once before.
Yeah.
Caps lock?
Yeah, I'm trying.
Doesn't like it. Well, you may have it already in there. We may have it over in our go up to there. There you go.
It's all custom CAN. Yeah, that works.
There you go. That should be.
Yeah, unfortunately, this is the one that's complete. So maybe we may just punt a little bit, and we can talk about it as if we were going to do it. Does that seem like that makes sense?
Mm-hmm. There might have been another one in there that was the copy. I think one underneath the trail break topic. But there you go. That one there. Maybe it's in there. Oh, yeah, that's odd. When we tested yesterday, this did not happen.
Yeah.
So okay. Well, now you might want to go back.
There we go.
To the,
I finally got it.
Yeah.
Okay. So as we talked about, right, it's good to have a backup. So I basically cloned this, and I'm going to save this with a new name that will represent that we're adding the PDM to the mix. So as I mentioned, right, the first thing we're going to do is I'd like to just be able to log whether a button is on or off, right? That's probably a useful thing you'd want to know from your PDM is like, did the user turn it on or off? What was its state? And so once again, we're going to walk through the same exercise of just copying and pasting these this data, right? So I'm going to say, Robbie, there's no ability to edit this, which is.
You should just be able to hit the plus button.
I'm not seeing a plus button. Oh, gotcha, to the right. Sorry.
Mm-hmm.
There we go. Excellent. We're back on track here. So once again, we're going to start out by copying the identifier, and we don't necessarily need to know like why the identifiers are what they are, but in this case.
Right, you can think of it as an address. You're sending a message, and this is the address that you're sending it to.
Exactly. And so we know from the documentation that this device is Little Indian, and I could scroll up if the scrolling was cooperating, but I just happen to know from the docs that this particular hardware is Little Indian. And we just copy the CAN ID and say okay, and then that will give us a new row that we can start to edit. And this is sort of where we start to get a little interesting because we're only interested in basically, I guess you could say, bits, right? Because we're looking at whether we have 12 buttons. I just care if each button is on. All right, so we're going to give this a name. We're going to say this is called button 0 or button 1 because we're going to talk about these in terms of buttons. And for use later, like elsewhere in the AiM config, there are places where a short name pops up. So it's good to have a unique short name. It does have to be unique, which is somewhat interesting because you only have 4 characters there. The next thing we need to fill in is the function. And this becomes really interesting because elsewhere in the AiM sort of universe, whether you're looking at it in analysis or in a dash, the environment is smart about what value you're carrying there. Is it a pressure? Is it a temperature? Is it a voltage? Is it an amperage? Is it a status? And so you could just put a raw number in here, but by actually telling the software what it is that you're tracking, you sort of get some better value out of that software later.
Right, and it's for, and in this case, we're going to use a number or just the 0, 1, or we could encode it as on off to make things easier. But on the bigger picture, if you have a pressure, you can then pick PSI, KPA, bar, and it helps organize and display the data more meaningfully on our dashes as well as in the software.
Exactly. And in this case, right, so under number there's all of these sort of subtypes, and you see a bunch of different things: session number, session split, numeric status. In this case, digital status happens to be the same thing as true, false, or status variable, right? It's just either on or off. And so that's telling the AiM software to just always think about this as either just true or false, or on or off. And the last thing I need to specify is I only need 1 bit here, right? Because all we care about is there's a bit for each switch.
Right, because what are we sampling? We're looking at the state of a button. There's only 2 possibilities: it's on or off. So we can comprise that all in 1 bit.
And so, so we copied and pasted the identifier. We know it's extended, which means it's a long identifier, not a short one. It's the direction it's coming from the microPDM. The broadcast rate here is given in terms of milliseconds, whereas the AiM dash environment thinks about things in terms of hertz. So I think 25 milliseconds is 40 hertz, which we can't quite do. So we're just going to say it's at 25 hertz, and that's close enough. Seem good?
Yeah, absolutely. And then while we're here, Andy Whittle had a question. Can you split bytes, like grabbing 12-bit data streams? Yes, you can do nibbling. You can do, you just, where he edited the number of bits to 1, you could edit the number of bits to 12, and we support up to a 4-byte message. So that would be 0 to 31 bits of information can be comprised in 1 message.
Exactly. And that's the cool thing here is like, I wasn't going to do it, but I may just show doing a second because we can just show how easy it is. Then we just say the next byte for the next button. If we do that, right? So if we were going to sort of dive into the example that Andy talked about, if I wanted to talk about button 2, it's just going to be the next button, the next byte. Sorry, the next bit.
And then for those that are interested, why have a short name? It's what actually gets displayed on the display. So why do we use a short name? Because sometimes we don't want to put water temperature on the display. We want to say like a water T or H2O T. So the short name is what will be used to display on the hardware.
And then we come back and we do the same thing: digital status, 20 hertz. And it's that easy. Now you can see there's actually 2 bytes, right? I've got the 2 bits. There's the blue one that we configured previously, the yellow one that we're configuring now. And we can see how we're moving across the byte for each button. So button 1 was the first bit, button 2 is the second bit. And so if I bail out of this, and I'll show you what a finished version of this looks like. You can see there are actually 12 bytes because there are 12 buttons configured. And that's what the CAN looks like at this address that ends in E13. There's these 12 bytes that we care about. And again, kind of interesting to the question I was asked earlier, right? We don't care about the last 4 bits. We're just only taking the first 4 bits of this byte.
And while you're here, there's one thing that you may or may not have used before, but the encoding values. I love them. I use them all the time because we're dealing with numbers. So it's a 1 or a 2 or a 4. But you may have a different meaning for that. Like, is my all-wheel drive engaged? That could just be a binary. It could just be a 1. It's true that your all-wheel drive is engaged. The encoding values allow you to set an ASCII character or an alpha character to a binary number. So it can say on your display on or off and give you a little bit more.
Well, that's one of the things I meant to play with first. So that's a great utilization for status variable. Rather than being 0, 1, it can just be on or off.
Right.
Or working or dead.
Yeah, so sometimes the flags for a vehicle, it's just all-wheel drive or traction control. It's 0 when it's on, and when you turn it off, the flag goes active. So 1 is actually the off state. So it can be kind of tricky when you're dealing with OEM manufacturers and how they organize their CAN bus. So the encoding value just takes all the guesswork out of it. You just say that this is on, this is off.
Exactly. And since we're running a little tight on time, I'm just going to do a quick run through on adding the second variable, the second set of inputs from the PDM to the dash. In this case, it's current sense, which is how much current each circuit is using. And we would follow the same procedure again, right? There's sort of copy and paste. There are 4 identifiers. It says that identifier that ends in 14 is for outputs 1 to 4. Output identifier that ends in 15 is for 5 to 7. And then if you have an add-on module, which I do, there's 2 more sort of buckets that you would get data from. And then the documentation again just says that there's 2 bytes for every output. So it says current sense output 1, least significant byte, and most significant byte. And we can see that here in the configuration. I have address that ends in 14. This is my current sense 1 for my first output. And you can see it's defined as 16 bits. And I knew that because there are 2 bytes involved here. And the AiM software just fills this in as taking up basically all of the 2 bytes. You would also set a sampling frequency. And one interesting thing, and this is where we can kind of get into like craziness with CAN, is looking at conversion factors and things like that. We're not necessarily going to get into the hows, but we're going to look at the documentation. So this says, if we look at the documentation, it says it's a little endian numbers ranging from 0 to 4095. To calculate current in milliamps, you'd multiply each number by 2.2. Now, in my case, I actually want the number in amps because, as I mentioned earlier, right, the AiM software can do interesting things if you actually say that this is a value in amps, not milliamps. And so to get to milliamps, I actually would multiply it by 0.0022 instead of 2.2. And that converts the milliamps to amps. And so then you basically get the scaled value displayed. And again, you don't need to know anything about scaling, you need to know anything about the math. You just need to be able to say, oh, the vendor says multiply it by 2.2 to get milliamps. Punch that number in here in the scaling factor area, and you're done. As they would say, it's that easy. So
Ray asked the question that you just set up these buttons. Give us an example of what on your car. What are those buttons doing?
Yeah, so I have I have buttons for my cool shirt. The microPDM supports a timer built in, so I have one button that's on all the time and one button that cycles on and off. I have another pair of buttons for defroster with a 10-minute timer and a 30-minute timer. I have a bunch of buttons that just sort of default to on that are for various accessory circuits in the car. I have a button for the rain light that turns the rain light on flashing. And then there's another button that's dedicated to the brake light function. And that's sort of a peculiarity of the way the microPDM thinks about things. Every output that you want to command has to have a button associated with it. So even though you would never really use a button to turn on your brake light, you have to have one. Now you can have it configured so that it doesn't light up, it doesn't do anything, but it's sort of the peculiarity of the way the nice thing about the microPDM is it was meant to be configured without any software, without a computer. You can configure it all from the keypad. And so you sort of have to think about everything as a button.
Gotcha. Okay.
So yeah, so I have a few extra buttons left over, but pretty cool. Hopefully we answered
room for more.
Yeah, we answered some quick questions. And
did you just cover did you cover Eldon's question? I think you've kind of covered a little bit of the scaling factor.
Yeah, the scaling factors. I guess it depends. Our proprietary bus it's constantly evolving, and that's why we keep it locked down, because when we change it, if it was published, we'd have to republish. We'd have to notify vendors, and our ecosystem works so well because it's only our systems that are designed to work on that. So we do constantly modify it, make changes for new things or correct incorrect things. But the CAN output as well as the ECU driver, you get to define them now, which is nice. There's no industry standard. You're the industry standard. If you want to send it with 5 decimal places of precision, you can do that.
And the question that Todd asked real briefly about the Rio, yes, you can map switched inputs to actions, and you do that via the trigger commands. So you can see here I have a button called Raptor 1 that's configured as a digital status, which was the same thing we used earlier, right? Digital status is either on or off. And you can actually see the same thing here, right? Off is 0, on is 1. And the really cool thing is in the Rio, you can set things up to be momentary, toggle, or multi-position. A multi-position would be like low, medium, high, off. And you could sort of cycle through things on your button. So the first thing we would do is define the button, and then we would go to a trigger command and basically map the Rio action to some action on the dash. Right. So in this case, I have my Raptor 1 steering wheel button set up to do on the dash just to simulate pushing button 1. If you want to play around with this, this is interesting. It's only configurable initially in beta. So grab the Race Studio 3 beta software. You can add add it to the CAN expansion tabs, and then you get all the other functionality. It's kind of surprising it actually works in Race Studio 3 non-beta once you add it to the config. I was not sure if it was going to work, but you can reset alarms. You can do display pages. You can actually go to a particular page, which is kind of handy. If you have a race page, you can just jump right to it. So the Rio is really cool. I have the RBI, which I'm using for 4 buttons, but ultimately I think that'll be the replacement for all the button stuff. So hopefully that answered your question.
Perfect.
So should we jump back to the deck? And
I will.
we're running a little bit long, but can bring this home almost on time.
Jump in there. Let's jump ahead right to here. There you go.
So I wanted to keep this sort of really high level in terms of the not diving into the deep complexities of CANbus, but there are some things that you need to know, right? Generally, if you go buy a device from somebody, it's going to operate either at 250 kilobits a second, 500 kbit a second, or 1 megabit a second. Almost anything these days is going to be 1 megabit, but you will occasionally find some things that aren't. And the one thing to think about, right, is everything on your CAN bus has to be at the same speed. You can't mix the speeds. And that's one of the things that's kind of cool about if AiM is going to open up the CAN 1 to be able to support multiple devices more easily. Having like one bus at 500 kbit a second and one bus at 1 megabit a second may enable you to use things that are maybe a little less flexible. But I think anything new these days is going to be 1 megabit without a problem. And we talked a bit earlier, right? CAN bus is a twisted pair. It's balanced. It runs over 2 wire, and that gives it the ability to reject noise and sort of be very resilient in the face of a really noisy automotive environment. The standard says that you can be 40 meters long at 1 megabit a second. I mean, I have a small car. I couldn't imagine 40 meters of CAN cable in my car, but that's pretty long. And one thing to think about is each time you branch off of the main CAN bus, your stub can't be longer than 0.3 of a meter or 30 centimeters. And the way to think about that too is you can't have basically a network that looks like a Y or an X, right? You can't have a bunch of equal length stubs. And the reason for that, just without getting too technical, is on the physical network itself, you need to manage reflections or sort of transmissions that sort of echo back. And you also need to manage how devices get access to the network to start talking on it and know that somebody else isn't talking on it. And if you create a crazy shaped network, you run into problems there. That also then leads us into the question of termination. The bus termination is also a critical part of CAN bus operation. Each end of the bus should ideally be terminated with a 120 ohm terminating resistor. And a lot of modern devices have a built-in terminating resistor, like the AiM dashes all have an option that says whether you can turn it on or turn it off. There are some devices that have a fixed terminating resistor, and those become a little bit of a problem because if you had more than 2 of those, your bus could be a little challenging. And more commonly, you'll find devices that don't have any terminating resistor on them. And the other thing to think about is as you're starting to design your network, and depending on how many devices you're going to have, think about using a CAN hub. I found the AiM makes a really cool 4-port CAN hub that's pictured here. Uses the DTM 4-pin standard, which is really great because you can do power and ground all in one connection. And the hub makes it really easy to do troubleshooting. Like if you have a device that's acting up and you need to disconnect it from the bus or make it the only thing on the bus with your dash, you can just unplug everything without having to sort of deal with like de-pinning things or unplugging things.
And the DTs or DTMs, it looks like,
Yeah.
those are really easy to add terminating resistors to. So if you do have devices without resistors, it's a great way to externally terminate your bus.
And
so ideally,
AiM actually sells it's rip-off money, but they sell for about $9 a DTM socket with a terminating resistor in it, and you can drop it in. Haltech also uses the same 4-pin connector, but they use a different pinout. So if you decide to go down this route, pick a standard for yourself. Just know that that's what you're going to wire your devices to, and you'll be happy.
Okay.
Jump on to the next section. So as we talked about, right, troubleshooting, we don't want to get into like basic, get out your CAN analyzer, but what can you do as a new person to CAN? So first of all, as we mentioned, right, everything on the bus needs to be the same speed. You should think about termination. So if you grab your trusty volt ohm meter and put it across the CAN high and CAN low, with everything powered on, you should see roughly 60 ohms. If you see less than 60 ohms, it means you probably have too many terminating resistors and you need to take one off. And if it's greater than 60 ohms, like maybe 120 ohms, that tells you only have one terminating resistor on the bus and you need to add one.
Right, and so low would be 33 ohms, high would be 120 ohms, and you want to be in the middle at 60 ohms.
Exactly. And I will say again, like my example of the crazy speaker wire running between my ECU and the dash, I found out later that the ECU was actually unterminated. So it was running, it's basically over speaker wire, no terminating resistor on that side of the bus, and it just worked, right?
It still worked, right? Yeah, it's high. It's a very reliable. That's why we use it. And I mean, production level cars that need to work every day. This is why we use it.
And so the other thing you can do with your trusty voltometer is if you, again, look between one of the CAN lines and ground, if you measure 2.5 to 1.5 volts, and you'll actually see the value changing kind of in real time, that tells you that's the CAN low line. And if you see it jumping between 2.5 and 3.5 volts, that tells you it's the CAN high line. So if you're tapping into maybe an existing function and you don't know how it's wired, or if you're maybe just not sure if you pinned your stuff out correctly, it's an easy way to check whether you have the wiring correct. And then, as I said earlier, right, a CAN hub makes it really easy to just unplug something and see if the bus changes, see if the device works better.
All right, divide and conquer.
Totally.
With so many systems all talking, trying to diagnose an issue, you just start working one at a time. This works. This works. This works. This works.
Yep.
This does not work. Got it.
Exactly. Yep, and that's what I sort of had to do that with when I put the RaceVoice and tire pressure monitoring system on it the first time, because I was the first person to get it running at 1 meg, and it didn't work. And worked through a bunch of stuff, and it worked perfectly after. So jump on to the next slide. So other things that are really handy if you're trying to troubleshoot, if you're just not sure what's going on with your CAN devices, this is an example of a status page that I built for all the things that are on my microPDM. The values on the left are just statuses, right? And this is from the configuration, so it's just showing fake numbers. But these would be either 0 or 1, showing whether the button is on or off. And then on the right side, it's actually showing the current, the current is passing through the device. And I think now that Robbie suggested the trick of mapping, I'm actually going to change these from 0 to 1 to on or off. I think that'll be the next project. The other thing, if you're trying to troubleshoot some weird CAN stuff, and particularly you're just not sure if the protocol is right, Robbie had a really good walkthrough at this link from one of the previous CAN 101 seminars, where he talked about basically building a device on one of the CAN networks and then building another configuration on the other network to receive it. And so you can actually see you sending data out via the CAN stream and then receiving, the CAN output and receiving it back over CAN stream, and see if what you think you're doing is right. Like that'd be a good way to test out, like, well, what does a status variable look like if I send it out over the CAN bus as a bit? Is it really 0 or 1? You could easily determine that.
Right, and
it's
also
really nice app if that didn't work. I was like, why didn't it?
It's also a great way to practice. You have two CAN buses. You can build your CAN output and build your receiving protocol on CAN 2 and make sure that it's doing exactly what you expect it to do. So when you get the hardware, it's ready to go. Exactly.
And then lastly, if you're stuck, there's lots of community support, whether it's for the product that you bought or just like there's like the motorsports wiring groups on Facebook. There's lots of folks who will happily help you out if you're stuck. With that, I think that's the end of our talk, only just a couple minutes late. So.
Perfect. It's such it can be a deep subject, and to try to fit it into the the 45 minutes that we have available is difficult tonight, and you did a great job. Thank you very much. I'm gonna start up a poll, kind of a post session poll here about things you might want to learn a little bit more about while we talk about the YouTubes and the next couple of things we're going to have coming up. There's a poll for you there. This one's multiple. You can select multiples here. So if you read through those and select some of those and submit those, and I'm going to talk about that. This video is going to head up onto YouTube within an hour or two. It'll be up there, and we went through a lot, and this is going to be one of those where and as I always say, we do that kind of on purpose to get as much information out as we can. and expecting that you're going to go visit our YouTube site and rewatch it a little bit and try to understand what maybe some of the smaller little details of what we hit upon. So it'll be up there here shortly. That'll make 148 videos we have up there. So there's a lot of information, not just this particular one here today. So go check that out. We're a customer support company. Make sure you give us a call. Like Jeff mentioned, there's lots of places to do that, and another one, of course, is Robbie and some of our technical staff. Give us a call at the 800 number, and if you have any questions, and let's get you through it and get you up to speed. So,
right, we're always here to help.
Exactly. Oops, and kind of our next webinar slide, I think, is going to be great fun, and some of you are really going to enjoy this. What we're going to do is we're going to bring in a fellow that's come in and talked about the PDMs more specifically in the past, but Fabrizio is going to join us and talk about AiM Sports hardware. Well, one of the things that a lot of people have asked for and maybe would enjoy seeing is maybe chat about how AiM Sports comes up with with this device and the process and talk about some of our new products that have been released in 2020. And some stuff that's coming up maybe, and answer your questions about the hardware. We've got some maybe a couple of focuses on this. Maybe AiM has some new pressure sensors that maybe we'll show you how they're built in the factory, and Fabrizio can discuss how they were designed and why they're such a great sensor, and of course the PDM and some other things. We're going to talk about hardware, maybe GPS, not just the GPS 09, the new sensor that we have out, but GPS in general and how that integrates with the different hardware. So a great discussion. We'll have some really fun with this one, I think, and talk with Fabrizio. He's very smart guy and in charge of the hardware team manager. So he is a hardware team manager. So that'll be kind of fun. So we'll do that a week from today on Tuesday.
That'll be cool. Looking forward to that.
I bet this will be a fun one. Yes, it will. Contact information for Robbie or Jeff. By the way, Roger here was sitting here learning along with the rest of you. I'm not too strong on this, so yes, I'm always invite the emails, but I think on this particular topic, you may want to contact these two fellows a little bit more than me. There's some contact information there, so I appreciate that very much. Let's end that poll real quickly, and let me share the results so people can see it. And again, it doesn't come across on the YouTube video, so the largest. The question was, now that we've covered the CAN basics, what are your top 3 topics you'd like to see covered in an additional or another webinar coming up? Number 1, reverse engineering CAN off of a production vehicle. Was the number 1 topic. How does that work? How does that happen? Well, maybe we'll chat about that. The next one up there is creating ECU drivers using CAN protocols. First one was 46%. That one is 44%. So fairly close actually. And the third place one was more detailed information on the CAN output. So we touched upon that just a little bit today, and some folks are looking for a little bit more information on that. So thank you all for taking the poll, and it's going to help us on our next steps as far as videos coming up on the CAN side. So I appreciate that very much. Jeff, just any closing words as we're kind of closing this webinar out that you'd like to add?
No, thank you for your time and the opportunity to share. I'm a really big fan of the sort of the ecosystem, and also love sharing information with other folks. And put a vote in once the more flexibility with the DVC and the ability to mix and match config files on ECU1. That'd be another great presentation for Robbie to do too.
Absolutely. And Robbie, anything you'd like to share on our way out?
I just hope that Jeff comes back, because we're gonna need some more help. And if you didn't see a topic that interests you, feel free to send me an email. I'd be more than happy to look at all where the user base sits and how we can better help get this type of information. We covered a lot today, and it would be nice to subset some of this information to give a more deeper dive for those that are interested, if you are interested.
Mm-hmm. Perfect. I appreciate it, guys. I know you guys put a lot of effort and a lot of work into this, and appreciate appreciate all of that effort. Thanks everybody for coming and joining us. Looking forward to next week. As always, it's my Tuesday mornings are always fun because of the webinars. So looking forward to next week with Fabrizio. Thanks everybody for coming, and we'll see you here on next Tuesday, a week from now. Talk to you guys soon. Bye bye.